Okay, okay. No, okay, then I'll try to do something else in this class. I was thinking we'll just go over the old problems itself.
Okay.
Yeah, because as you said, you are not able to see the new videos, right?
Yeah, a new
So
video. I don't know why it has not been published, and it is already mentioned in the like on 27th, I think, of this month. There will
yeah,
be
yeah,
examination, exams.
27th of this. Yes, yes, exactly.
So this week 12 is the last week, and that one is not been published till date. That's
The
what I
PDF
can
documents are
see.
there. PDF is available. The
Actually,
lecture
after week 11, there is no tab also for week 11, week 12.
week
There is
12.
an individual row is there na, for week 9, week 10, week 11.
Yes, yes, yes.
So there is no week 12. I've opened it now also. I'm just,
Actually, it has been released. It is saying it came 5 days ago.
I don't know. It is saying it has been released. You can start with the week 12. The lecture videos for week 12 has been uploaded for the course Polymer Reaction Engineering. It is saying
Okay, okay, okay. Let me log in with my
not
account and I will
okay,
see.
okay, okay, okay. Now I can see. Now I can see.
Okay,
Yesterday it has not been published.
uploaded. Oh,
Today now I can see.
no, because this message came 5 days ago.
5 days.
Yeah, 5 days ago it has come.
Regarding 12th week lecture, the message came to my site on 8th of this month, like yesterday.
Yesterday.
Yeah.
Oh, okay.
And it is also said the assignment has to be submitted on or before Wednesday, that is April 17th. And this video 12th, week 12 has been uploaded for the course, Polymer
One
Reaction
second,
Engineering.
1 second. Assignment has, yeah, yeah, yeah. Assignment has to be submitted on Wednesday, April 17th.
Yeah. And
Okay,
on
okay.
8th of this April,
Huh.
it has been uploaded.
Okay, okay. Yes, yes.
Now I can see. Now I can see. This
Yeah.
ionic polymerization 1, 2, 3, 4, 5.
Mm-hmm.
There are 5 parts and all related to ionic polymerization.
Okay, so it has come to you, right?
Yeah, yeah, yeah. Now I can see. And you have already discussed.
Yeah, I have already discussed from the last session.
Yeah, yeah. Week 11 already you have discussed.
Yeah.
And week 12 I actually didn't gone through. Not
Yes,
yet
yes.
started. Just now I can able to see actually.
It's okay, it's okay.
So
So that's what I was thinking that I'll just go through the previous assignment itself once more.
okay, you are thinking of going through today itself or
Uh, I can do it like now itself. 1 second.
okay, no issue, no issue. I'm ready.
Hmm.
If suppose uh, if I find something to ask, then I will ask.
Yeah, yeah, yeah. Definitely you can ask.
Actually, there are so many things uh, is kind of new for me only.
Hmm. Yes, yes. So you must have gone through the notes also, right?
Yeah, all the notes I've gone through, then the lectures also I've gone through. There are so
Okay.
many things, and I'm trying to.
Hmm.
There are a lot of things which is going above above my head. So
Yeah. Suddenly the number of items in this is very much. That's why.
mm,
Like, yeah, that's what you have to be very, like, you should know the theory of the every process properly,
mm.
right? So the first question, particle nucleation will occur due to both homogeneous and heterogeneous nucleation mechanism. If choose the correct options. So we saw this last time also, but let's go through it again. So you have gone through the notes also, right? So you might have come across the particle nucleation of homogeneous and heterogeneous mechanism. Hello.
Just a second.
Yeah,
Actually,
yeah, yeah.
uh,
It's fine.
yeah. Yes, yes, yes. So sorry, actually, I'm still in office, no. So
Oh, okay, okay.
in between, some one person has come to ask something. Yeah, yeah,
No, no, no. It's okay. It's okay. Like, if you are like just finish that work, then we can see this.
yeah, yeah, yeah. He has gone actually. Already finished.
Oh, okay, okay. Yeah. So you have gone through the lecture, right? This
Yeah.
week. Huh. So you should be able to answer the first question, I guess.
Homogeneous and heterogeneous. It is the case when homogeneous is when the monomers are completely soluble,
Hmm. Yes.
and during heterogeneous when there is not so much of uh, solution has been taken place.
Yeah, yeah.
For both the cases, like you have mentioned, the monomer are water soluble.
Yes, yes, yes. So it will be like that one.
Uh, Related to heterogeneous,
So the so how will that be? What is the criteria for homogeneous and heterogeneous to occur?
uh, I think the homogeneous is a situation when there is a complete uh, solution of the particle
Hmm.
monomer,
No, in
and
both cases, that is true what you said, that monomers are water soluble. So at that time only it will dissolve. Like it will, nucleation will occur in that case. So the first
yes,
option, that the monomers are
okay.
water soluble, is correct. Then if you explore the other options also, then you have to find out what is the CMC and how the micelle formation is going to affect.
Mysis is when it formed when there is a surfactant.
Hmm. Correct,
Uh,
correct.
uh, the surfactant in the surfactant monomer gets in the
Hmm.
micelles, this monomer get trapped inside, and
Yes,
we add surfactant to uh, untrap the monomers from the micelles.
yes, correct, correct. So the concentration of surfactant is very high, so that the micelle formation can occur easily. Is also the other reason why it will occur. Okay. So the first option and the fourth option is the correct answer for this question. Okay. We'll move on to the next question. Which factors affect the molecular weight distribution in emulsion polymerization? So now we have the molecular weight distribution. So what will affect the molecular weight distribution?
Molecular weight distribution would be depend on the initiator and the concentration.
Yes. Can you explain like in what manner?
The molecular weight distribution taken it would be dependent on how much we are initiating the polymerization. Like
Hmm.
it keep on getting chained, like in a linear form. It is getting added. And
Yes.
polymerization is
Yes.
taking place, and
Hmm.
there is a oligomer or free radical gets polymerized with one another,
Yes.
and it is keep on going. So in that case, the molecular weight distribution would increase.
Yes. You're right. So that is the one of the main reasons why molecular weight distribution is affected in emulsion polymerization process. Okay. So
Okay.
next one, yeah, next one is the advantages of operating emulsion polymerization under limited monomer supply maximizes the production rate. And so this is a pretty straightforward question, and you can tell that this statement is false because if you have a limited monomer supply, it is not like it won't be able to maximize the production rate. The yield won't be maximized.
Exactly.
Yeah,
Exactly.
definitely. Hmm, exactly. So we will just go to the next question. This is also a formula-based question only that the
Uh,
amount of surfactant. Yes.
In this case, actually, I found there are so many direct formula
Hmm.
uh, during the lecture I come across.
Yes, yes.
So it is just like you have to learn directly.
Exactly, exactly.
Just
It's a direct formula.
memorize the formula. That's it.
Yeah, because there it's like a direct relationship between for the heterogeneous nucleation, how it is occurring, and this is the first one. The first option is the correct formula. That is SW is equal to ST minus AP star by AS, where SW is the amount of surfactant that is dissolved in aqueous phase, which will form the micelle. SW can be calculated by means of overall material balance. That is the and ST is the total amount of emulsifier inside the reactor. So ST is what is present inside the reactor. AP star is the total surface area of polymer particles. How much it's available, that is the okay. So with respect to that, we are calculating it. So you'll have to just know the first formula itself. The definition of the individual parameters is given right here. APAS, you can see that. Okay. So the first one is the correct answer for this question. Next question is
Okay.
the rate formation of particles by homogeneous nucleation is the rate at which the radicals growing in the aqueous phase exceed the maximum soluble length. So you can see that the rate formation of particles by homogeneous nucleation, it is asking us the rate expression or the rate formation where you can see homogeneous nucleation is occurring. So the oligoradicals, which are uh, oligoradicals growing rate in aqueous phase, which when exceeds the maximum soluble length, it will give you the rate of formation of particles. So this is
After
true.
that, it will become heterogeneous.
Yes, exactly correct. After one point, it will become
When the
heterogeneous.
oligo radical gets
Hmm.
exceed the maximum soluble length,
Yeah, exactly. So that is the critical length. The critical length depends upon the composition of the oligoradical. So based on that, the differentiation between the radicals value from initiator and the other radicals help to define the composition. So the critical length is very much dependent, which will decide your homogeneous or heterogeneous part. So this statement is true.
okay.
Okay.
Savan sir, we have been waiting for you.
Yes, sir.
Hello, good evening.
Yeah, good evening, sir. We have been waiting for you actually.
Sorry, I was a bit late. Last week I could not join. I was in a tour. Sorry for that.
Oh no, it's fine. It's fine. We are actually just going through the questions from last week
Yeah, yeah,
only
please. Yeah.
because apparently this week's lecture has come late, so that's why we are just going through questions of this time itself.
No
So
problem.
yeah, so again now it is like we have a question that what are the ways to remove residual monomer which is formed? So what can be done to remove the residual monomer? If we have gone through the notes, you can easily just
Devolatilization is there.
yes, devolatilization is there. Correct. That is one important process.
And post polymerization process.
Correct. Post-polymerization process consists of inverting fresh radical generating system to polymerize the remaining monomer at the completion of main polymerization process. So what we are doing is when the polymerization is over, if any leftover polymer chains are there, we'll introduce some fresh radicals and polymerize them also. Okay. So the answer for this question is one and two. Points one and two. Okay. So
Uh, like fourth point. Suppose we
yes.
add fresh radicals.
Hmm.
So in that case also that residual monomer get polymerized
No, no.
can be done.
Uh, Actually, we are adding this in the intermediate stage. So at intermediate stage, you cannot tell how much residual monomer will
Yes,
remain.
yes, 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 yes.
Yeah. So that's why you have to like wait till the polymerization is over, and after that you then release it. Okay.
Okay.
Yeah. Moving on to the next question. Linear emulsion polymer can uh, only be formed if the average number of radicals per particle is greater than zero point 0.5. So this is like a
It's kind of direct question
direct question. Yes, it's a direct question.
from the equation.
Hmm, exactly. It's a direct question, and you will have to remember that it's it's not greater than zero point 0.5. It will be less than zero point 0.5 like that. We'll have to remember this part. Okay.
Yes.
Yeah. How are linear polymers formed in absence of chain transfer mechanism? So we saw the like we know the how it happens is that since chain transfer mechanism is not there, chain transfer means transferring the activity of one chain to the other. So if activity is not being transferred, it won't grow. So basically, linear polymer formation, how we can how it is formed is using the monofunctional monomer unit. So if monofunctional monomer unit is there, only single functional group is attached with the participating molecule. So that's how it's going to increase in length.
The presence of monofunctional monomer unit will lead to the linear polymer formed.
Yes, increase in the length of the linear polymer. So that will be helpful in increasing the length of the linear polymer.
Lengthwise, it will get polymerized.
Yes, yes, exactly. Moving on to the next question. Which two forces control interfacial polymer migration? So now it is asking us how the interfacial migration is being controlled. So here we have first van der Waals force, then viscous drag, then we have cluster formation, radical attachment on the outer layer or the outer layer of the new polymer. So you can,
In this, like I wanted to ask,
yeah,
here the polymer migration indicating what? The polymer migrating from which part to which part? That one actually I was like wanted to know
yes, yes,
actually. Know actually.
yeah. So what happens is that in polymer migration, right? First of all, we need to understand how it is happening. Basically, the polymer reaction can be found to occur at both regions. It is happening in the cluster as well as inside the polymer matrix in the interface region when it is being formed. Uh, Polymer matrix in the sense like when you have the emulsion form. In emulsion, you have the dispersion phase and the dispersion medium. So if radicals attach on the outer layer of polymer particles, new polymer will form on the periphery itself. If you have a polymer molecule like a circle or a bead, sphere bead, the radicals which will attach on the outer layer will start growing the polymer there. And if the polymer starts growing on that polymer itself, it will form a cluster like that. Okay. So it will result in some sort of cluster. So what happens is increasing the concentration of newly developed polymer chains, phase separation will occur, which leads to cluster formation. Definitely, if the amount of polymer which is growing on the side of that already existing polymer will make a huge mass and it will separate out. It will become like a single entity and it will separate out. Okay. So
Actually
how
get
will
precipitated.
yeah, yeah, kind of. So what happens in this is that polymer migration results to increase the size of cluster due to polymerization in the cluster itself. When the cluster is formed, it will continue polymerizing there, and diffusion of the polymer into the cluster. It will keep diffusing different polymers inside the cluster, and it will coagulate. It will just form a clump with other clusters. So it will just become like it will be localized. It won't be spread everywhere. It will just form the cluster in one corner. And it will increase a lot. So this migration is governed by basically two forces. First is van der Waals force of attraction and repulsion, and the second one is viscous drag. So that is the answer for these. How that affects is van der Waals force between cluster and aqueous phase can be attractive. So if these two forces are attractive, it will shift the cluster towards the surface of the particle. Okay, it will just bring it to the surface of the particle. And if it's repulsive, it will move the cluster to the center of the polymer particle. It's like that. If it is surrounded on all sides, then it will shift how it is going to attach onto the polymer. When and also the van der Waals forces are proportional to the interfacial surface tension, which is formed in the emulsion polymerization. Since we have the dispersed phase and dispersion medium, there is an interface force between these two. So your van der Waals force is kind of balancing the interfacial surface tension. So in that case, it swings between attraction and repulsion. And apart from this, when we come to viscous drag, the resistance to flow is arising from viscous drag. If the particle is very high, like very large, or the polymer cluster is big, then it will have a lot of viscous drag, and because of this, interfacial migration will be hindered because it will be experiencing more drag, so the velocity at which it will migrate will be low. Okay, so what happens is that if the internal viscosity of particles are high, then like a semi-stable morphology will be. Uh, Low interfacial surface tension will promote the grafting reaction. Grafting reaction means what? It will graft like it will form a layering that is called grafting. It will attach onto it and form a graft. So that's like a grafting polymerization process. On the other hand, if there is low internal viscosity, and that time equilibrium morphology can be achieved. In this case, the interfacial tension will be very high, and because of this, instability can be occurring inside the solution itself. Since the
Uh,
interfacial, yes.
just one thing. Sorry to interrupt. Here, this migration indicating whether it's a after the polymer get reached to a critical length, so
Hmm.
it get come out or get segregated from that particular point, and
Yes,
it reached
exactly.
to that point where we call it sedimentation or precipitation.
Uh, you can call it phase separation. It will just separate
Phase
out.
separation. Yes, yes,
Yeah,
yes, yes, phase
phase
separation.
separation.
So that phase separation part is called as a migration, or is it something else?
Yeah, it is exactly that. That's how it is going to migrate. Because as the polymer forms, it has to spread inside the entire dispersion medium, right? So dispersion phase is there. And then once the polymerization starts, it has to migrate everywhere. So that's how the polymer migration process takes place. So what is stopping this migration, or what are the factors which affect this migration, is what it is. So
That one is viscous drag and van der Waals forces, like you
yes,
mentioned.
exactly,
And one
exactly.
more thing that I've noticed in this question,
Yeah.
what I was thinking, here it is told two forces. Which are two forces? Like forces
Mhm.
they've already mentioned, and in the
Mhm.
option we can see this cluster formation is not a force, or radical attachment on the outer layer of a new polymer is again not a force. So it
Yes, yes,
becomes pretty obvious that
yes,
van der Waals force and drag, viscous drag is kind of force only. It's a
yes,
surface force. So
exactly, exactly.
from that point of view, I think uh, I
It will
don't
be
know whether
easier.
It is
Yes, yes.
relevant.
Yeah, but it depends. Like if the wording is changed, then you will be confused, right?
Yes, yes, yes. In
It's
that
just
case, I'll
about
be
the.
confused. Yes.
Yeah. And I think it is supposed to be a direct question because in the notes also you can see that it is directly given that it is governed by two interfacial forces. So you can directly see it. Okay, so moving on to the next question. Which reactors can model the Cout-Taylor flow reactor? So we have the Cout-Taylor flow reactor shown, Cout flow scheme shown here. What happens in Cout flow is that in Cout flow, either the outer cylinder is stationary or the inner cylinder is stationary, and one of them is rotating. So what happens in this? You're going to put your polymerization mixture inside the annular space. So in the annular space, when the inner cylinder starts rotating, there is a gradient formed between the wall and the center. So you can see right here that near the wall, and near the center. So the velocity of the fluid layer, which is very close to the centermost point, it will have the maximum velocity, and the one which is at the stationary wall, it will have the lowest velocity. Okay, so because of this, what will happen is that the Taylor number, there is a factor related to this called Taylor number, where initial inertial forces due to rotation divided by the viscous forces are involved. So when your polymerization is rising, definitely viscosity change is there and inertial forces due to rotation. So to allow mixing, what happens is the inner cylinder will rotate faster and it will be responsible for your mixing divided by the viscous forces. So that defines your Taylor number. So what happens is as the viscosity change follows a particular trend, Taylor number will be modified by the cylindrical by modifying the cylindrical outer cylinder with a conical one. You can change the Taylor number inside. And since we are talking about mixing, the mechanism of Cout-Taylor flow is similar to that of mixed flow reactor. Since mixing is taking place, right, and it's continuous mixing on the edges, and because of the gradient which is forming, since the viscosity gradient is forming because of the fast mixing and polymerization occurring at simultaneously at the same time, this flow is similar to that of a continuous stirred tank reactor in series. So the answer for this question is continuous stirred tank reactor. What happens is that when the inner cylinder is rotating, the liquid or the polymerization mixture which is present in the middle will counteract that force. Definitely, it will show some resistance to flow, that is viscosity. So that resistance to flow will create counter-rotating toroidal vortices. Counter-rotating toroidal vortices means because of the resistance to flow as the inner cylinder is rotating, the liquid will try to resist it in the counter direction, and because of that, small vortices are formed. These small vortices signify a single stirred tank reactor. So you can imagine that as multiple stirred tank reactors in series. So the analogy is something like that. So if you are able to like catch that analogy, then you will understand that continuous stirred tank reactor is what it is being talked about here. So Cout Taylor flow reactors show behavior of continuous stirred tank reactor. Okay. If you have seen the diagram and the explanation for it in the course notes, then you will be able to understand it much better, I would say. Here, what I have shown is just a small representation.
It will work as a continuous.
Yes, yes, it will work as a continuous one because the inner cylinder is rotating continuously at a particular velocity, and small toroids are forming in series on the outer cylinder itself because of the velocity. These toroids are forming why? Because there is a mismatch. between the inertial force due to rotation and the increase in viscosity. Because of the increase in viscosity, there is a resistance, and the inertial force of rotation is going to push it this side, and viscous force will push it on this side. So there is a formation of a vortex. So small vortexes are being formed. Because of that, it is giving it a continuous stirred tank behavior. So that is being described. Okay, it might take some time to understand that, but that's how it is.
Uh, just one question.
Yeah, yeah.
Uh, Suppose continuous stirred tank reactor, uh, indicating we are continuously feeding monomers and other radicals and all these things continuously inside the tank, and
No, no.
and in the tank it is getting reacted, and the polymerization, the output we are getting the polymerized product.
Polymer. Yes.
Okay, so
Mm.
here you talk like the desired molecular weight product or desired product which we wanted,
Hmm.
whether is it possible in this
Setup.
coated Taylor coat Taylor flow reactor?
It is possible. Actually, for emulsion polymerization, this will be very much important. Why? Because since we know that there is dispersed phase and dispersion medium, it is important to facilitate the reaction with some rotation, definitely. And when you create such an annular space, the annular space which is created here,
Here
that
in
is,
place of stir, we are using inner cylinder.
yeah, exactly. So what it does is that it is creating a lot of what should I say, gradient forces in the middle of these two layers, the inner cylinder and the outer cylinder. So in that case, the reaction will be quite fast, and we will be able to achieve our desired yield also.
Okay.
Hmm. So if the what happens is that, but the main problem because of this is that uh, coagulation can occur. Why? Because since the annular space is there, so if the polymerization mixture increases a lot, your viscous forces will overpower the rotational forces, and sometimes because of that, the polymer might settle down. So that is one of the problems which can be faced in this case. Okay, so remember these things because these are the small things which can be asked for as questions in the exam. Okay.
Okay.
Yeah. Okay, then that's all it was. That just this was like more like a revision class because we haven't gone through the this week's new lectures, so that's why.
There is one question
Yeah.
which was came across. So can I just
Yeah,
share
yeah,
that question?
yeah.
Just a second. Just a second. Let me just see the question. What exactly it is saying?
Is it related to emulsion polymerization?
Yes. Yes.
Okay.
This week. This week related to this week.
Yes, yes.
Just can we scan through the initial questions if you don't mind?
Yeah. Sure. Before you came, only the first question with like one, two. Yeah, only the first three questions we discussed around. So the first one was that particle nucleation will occur due to both the homogeneous and heterogeneous nucleation mechanisms if choose the correct answer. So what happens in homogeneous and heterogeneous nucleation processes is that it The homogeneous and heterogeneous during homogeneous and heterogeneous nucleation, monomers should be water soluble. Only then the nucleation process can proceed. So in the four options, you can see that the first one is the correct answer, but we have to see the other options also. In heterogeneous and homogeneous nucleation process, the
Just a
formation.
small request. Can we, sorry to interrupt, can we make it in slideshow mode so that the points are
Oh,
very, yeah,
okay.
yeah,
Now is it visible?
yeah, fine, fine. It is clear.
Yeah. So in heterogeneous or homogeneous mode of nucleation, the there are different factors which are responsible for the nucleation mechanism. First is that the first condition which should be applicable for the homogeneous and heterogeneous to occur is the monomer should be water soluble, and on top of that, the micelle formation because of the surfactant which has been added should be high enough so that micelle formation can occur easily. And since if micelles are not present, the emulsifier will form through the existing polymer particles. So that's why the concentration of surfactant should be high enough that micelle formation can easily occur. And emulsifiers are generally used for stabilizing the particles formed through homogeneous nucleation. So that's why the fourth option, the concentration of surfactant is very high that the micelle formation can occur. This and the monomer water solubility governs the homogeneous and heterogeneous nucleation process. So first one and the fourth one is the correct answer. Then we have what factors affect the molecular weight distribution in the emulsion polymerization process. So in emulsion polymerization process, definitely you can see it from the options itself that which factor we have the initiator type and concentration of the initiator will affect the molecular weight distribution, as initiator will facilitate the growth of the polymer chain and result in the molecular weight distribution, you know, which will exactly describe how the different chain lengths are being formed in the polymerization process because of the initiator type, what kind of initiator is being used. So first one is the correct answer. And then the
Whether we are
statement
not,
of
whether we are not looking for the concentration of the monomer, because uh, we are discussing about the distribution, molecular weight distribution part only.
yes, yes,
Okay, okay, okay.
yeah,
So only initiator type and its concentration will have this impact.
yes, yes.
Okay, okay, okay.
Then we have the advantages of operating emulsion polymerization reactor under limited monomer supply maximizes the production rate. And so you can clearly see that advantages of operating emulsion polymerization reactor under limited monomer supply maximizes the production rate and yield won't be correct because other factors are also included in this. But since the monomer supply is limited, you cannot maximize the yield. Yield will be limited, but the distribution form will be quite controlled. So that's why what happens in this is that uh, the monomer supply maximization is required, and limited monomer won't be able to give you high yield. So that's why this statement is false. And then in this question, this is a pretty straightforward question, and it's a direct question. So the first formula itself will give you the answer for this. That what happens to the surfactant dissolved in the aqueous phase and how it is related to the emulsifier inside the reactor and total surface area of the polymer particles AP. So the first equation is the answer for this question because it's a direct question which is describing the
Yeah, yeah, in
relationship.
lecture also it is described. Yeah.
Yeah. Uh,
Whether that is
part
that much only because I am
You have other class also?
No, I have a small doubt. Actually, there is some when I see the total number of questions, it was 11,
Hmm.
but I could not see whether I have fully checked because
Oh, okay.
any other question is pending because I joined during this linear emulsion polymerization where the average number of radicals.
Okay, okay.
Sorry,
Yeah, yeah.
the residual monomers also is there. Yeah.
Hmm.
Okay.
Okay, so residual monomer question we'll see.
Yeah.
What
So
are
this
the
one
ways to
I
remove?
have joined. Yeah. Yeah.
Yeah,
This I have joined. Post polymerization process as well as devaluation. Before
yes.
this,
Uh-huh.
okay.
So this
Okay.
only one question is left. That is the rate of formation of particles by homogeneous nucleation is the rate at which the oligoradicals growing in aqueous phase exceed the maximum soluble depth. So,
Okay, that is true. Yeah.
mhm. Partha, did you find your doubt? The question which you
Yeah,
are having?
can just one question. It the question says the reaction dash and the dash in the feed in semi-continuous stirred tank reactor can be adjusted depending upon the composition and the volume of the initial charge.
Mhm.
Number two, composition and flow rate of the feed.
Okay, so
So
this is
that
for emulsion
dash is
polymerization?
what? Yeah. Can I repeat?
Yeah, 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 just repeat once more.
The reaction dash
Mhm.
and dash
Okay.
in the feed in semi-continuous stirred tank reactor
Mhm.
can be adjusted depending upon
Can be adjusted depending upon.
number one,
Mhm.
the composition and the volume of the initial charge,
Okay.
and number two, composition and flow rate of the feed.
Okay, flow rate, composition.
And the options are for that dash. The options
Oh,
are yeah, it is well, the statement is like this. The
mhm.
options it is mentioned. One is temperature, number two is polymer composition, number three is time, and number four is volume.
I think volume of the initial charge, right?
Yeah, actually, uh, as far as I understood from the
Mhm.
semi-continuous, it
Yes.
is time dependent.
Hmm,
We are not
exactly. It is time
continuously
dependent.
charging the fluid or reactant or whatever, like if
Hmm,
you call it as monomer and initiator. So we are
that's right.
continuously charging, and at the same time,
Yeah.
we are getting the final product as output. It's a simultaneous thing. In the case of
Yes. Hello? Yeah.
continuous,
Yes, yes.
so it's a time dependent, also the volume dependent.
Exactly. Like that's why volume of the initial charge and flow rate of the feed also.
Yeah, flow rate of the feed also,
Yes.
it is the responsible thing. But
Hmm.
anyhow, somehow I get to know the answer is it is mentioned as temperature and polymer composition.
Temperature and polymer
So
composition, right?
it is been like said the temperature and the polymer composition is the right answer, which I
I
actually
think
did
it
not
should be
able
like,
to understand and relate.
okay, let's take a look at that sentence itself. The
Yeah,
reaction dash and dash, the polymer composition in the feed can be adjusted depending upon.
the
So what is
reaction
happening?
dash and the dash in the feed in semi-continuous stirred tank reactor
Can be
can be
adjusted.
adjusted depending upon
Hmm. Okay.
number one
See,
is the composition and volume of the initial charge and the composition and flow rate of the feed.
feed, correct. Okay, so what happens is the first of all, polymer, uh, the reaction temperature and the polymer composition. So composition is there in both of them, correct? So polymer composition will be changing with respect to that. The reaction temperature, how it's happening is the volume of the initial charge or the flow rate of the feed. If you're going to increase them, definitely higher amount of like with that control itself, you can tell how the temperature of the polymerization process will take place. That's how you're controlling. Okay. So if you're sending in like a set amount of volume, so you will know for that how much polymerization will occur and what will be the temperature increase. So that's how you're controlling the temperature and the polymer composition.
Mm, here actually, uh, it is already in the question mentioned. It is adjusted depending upon the composition and the volume of the initial charge,
Yes,
the composition and flow rate of the feed.
yes, yes.
At what rate we are maintaining the composition
Hmm.
during the feed, and also the volume of the initial charge.
Volume of the initial charge and flow rate of the fluid. So it's kind of similar. These two parameters are kind of
Yeah,
similar.
these two are kind of similar. Yes, yes, it's
Yes,
kind of
exactly.
similar.
Yes.
Mm.
Both options are kind of
So,
similar. It's like
yeah.
the initial charge means how much volume you're going to feed initially for the
Yeah.
polymerization process to start, because that will govern how the temperature will change, right? The reaction temperature. Definitely.
Mm.
Yeah, definitely. If you're supplying in high amount of initial charge, definitely, if any unreacted monomers or anything is remaining, that will keep reacting and keep increasing the temperature, right? Reaction temperature, because your initial charge is very high. So what you can do is you can send in some low amount of initial charge and then slowly control the flow rate of the fluid. So with that also you can control the temperature. Correct.
Here, here the reaction, what we call this temperature and polymer composition, that one we are adjusting by the
By
initial charge and the
using
flow
the
rate, you mean to say,
yes, exactly. Yes. It's like this. If I'm
or vice
using,
versa. It can be
yeah,
like
vice
also,
versa. Exactly, vice versa also. Something like that. Yes.
like temperature and polymer composition is constant.
See, if you're going to give a higher volume, more time to react, or more flow rate and more parameters to react, it will definitely polymerize further and increase the temperature, right? So that's why volume of initial charge is very important. And after the initial charge, how you are supplying the rest of the feed also is important, since it's a semi-continuous process. So in semi-continuous, initially how much you are giving, and then as the process goes on, further how you are supplying the feed also will definitely control how the reaction temperature will change, if it will increase much or decrease. It's like that. Okay.
Okay.
But the main limitation in this process is that it's having low productivity. Okay. That is the major
Uh,
drawback of this process.
just contrast to continuous.
Hmm.
Continuous,
Yes, exactly.
what makes it difference from the continuous? Like what is making it not batch? Why it is particularly semi-continuous?
No, because in this case, what we're doing is that when we are supplying the initial charge, and then after that we are letting the reaction occur. Okay, and then we are like what we are doing is semi-continuously we are sending it, like small batches we are sending. Continuous, what happens is
Small
that
batches.
yeah, small batches we are sending. That is called semi-continuous, right? A batch reactor means you send one batch and then you let it happen, and then
Until and
that will
unless it get completed,
yes,
we are not putting another batch.
exactly.
And in
Yes,
semi-continuous, in the ongoing process, small batch of composition we are feeding, and in
yes,
between the process we are getting the output, and also in between that we are again feeding.
feeding it. Yes, exactly. So that is the reason. Okay.
Okay.
Yes, that's it. You can find this. I think you can see this in Sir's notes itself. He has given it in the emulsion polymerization week 11 second lecture. Second or third lecture it is there. In that itself, I think.
Actually, things get clear when we like discuss in the forum. So
Hmm,
in this way, many things get clear.
exactly, exactly. Because I think what you need is like a pictorial representation. Like through a picture, you can understand much better that how differential and how continuous will work. How continuous, differential, and sorry, not differential, continuous, batch, and semi-batch will work. Semi-batch, semi-continuous, you can call it like that. Okay.
Okay.
Yeah. Okay, then this class was more like a recap class, I think. So we have seen all the questions, and in next class we will go through the week 12. So this time you will definitely have time to discuss the week 12 lectures now, so that next time you will be able to answer directly whatever questions we will be discussing here. Okay?
Rahuji, one small request.
Yeah.
Sorry, Rahul. Now, small
Yes.
request. Can you just scan through the questions because I still I could not find one set because I was barely taking a screenshot also.
Oh, okay.
If you
Just one thing, can I take leave? Like, if you
Yeah,
permit
yeah,
me,
yeah.
I have actually
Sure,
to go
sure, sure.
home now.
Yeah, 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 sure, sure. You can.
Thank you, Ron. Thank you, Savan sir.
Yes,
permission,
yes.
Uh,
bye.
Thank
Bye.
you. Bye, bye.
Okay. Bye. See you. Yeah. Okay, sir. I will
Can you
go
just
to.
make it in screenshot slideshow mode? Just
Yeah, yeah, yeah. Yes,
this
yes.
I have noted. Yeah, this I was clear. I have noted it. And what are the, yeah, this also initiate type and concentration. Yes.
Hmm.
Then maximizes the yield. Advantages of
This was
limited.
false. Yes.
Okay. Just to know what is the reason behind that they were telling is limited monomer supply will improve the yield emulsion part.
No, no. This is actually false because it's not an advantage. It is a
It
disadvantage,
is
right?
so when we reduce the limit the supply, then it is not going to improve the yield, right?
Yes, definitely. Yeah. Yeah.
Because yesterday I think there was some misunderstanding in this question, so it was slightly different answer was there yesterday.
Oh, yesterday.
Yeah, yesterday also similar discussion happened,
Okay.
but it was told true. That's why. Okay, no issue. Anyway, then
Oh, so were you able to rectify it? What was the correct answer then?
no, actually, I was also arguing for this point only. Like when monomer is less, we should have
Hmm.
limited yield.
Yeah.
But probably the answer given yesterday was like it is true. I will just
Okay.
open that file also. Probably if I am wrong, also I should be corrected myself. Just one second, I will open that also.
No, no, that's fine. But did they explain why it's true or false like that? Did they explain to you?
No. It is mistake from my side. It is false only. Yeah, sorry, it is false only.
Okay. Okay.
It's a
Yeah.
mistake from my side. Sorry. Yeah,
Uh,
next one. Yeah,
and
this
then.
also is a straightforward first one. Yeah.
Hmm.
Then formation of oligonodules exceed the maximum soluble length. Yes, it is
True.
true. Yeah. Then
And then
what are the ways? Yeah, post polymerization process and devoltation. Yeah, this also.
devolatilization. Yes.
Yeah. Then this also, yes, it should be as per that equation. It should be false. Yeah.
Hmm.
Then here, yeah, how linear in the absence of. Okay, so only my monofunctional is there. It will not extend further. So chain
Yeah. Yeah.
extension is
Hmm.
otherwise it will be extending. So this is the one question I think I missed there.
Oh, okay. Okay. It's all
So
right. Yeah.
here it is. The answer is I think second one.
Yes. Yes.
Presence of. Okay, that much only. Then can we just scan through the list of van der Waals? Yes, this also. And this one, can you just go to the reactor picture? Yeah,
Yeah. Yeah.
this you are explaining like inner cylinder is rotating means we should consider this as a still tank reactor, right?
Continuous. Like continuous stir tank reactor in series. Not because
Okay.
the inner cylinder is rotating, because there
Okay.
is a difference between the viscosity increase and the rotational speed of the reactor. So because of
Okay.
that, small vortex are being formed. Those vortex act as a continuous start time wave. Okay,
Okay. Okay.
yeah. Like I would have shown you a better representation, but I don't think I'll be able to draw it here. It's like on this since the viscosity of the polymer is increasing as the reaction progresses, the rotation because of that there is a mismatch in the rotation uh, velocity, and because of that, small toroids are being formed. Toroids means it's like a vortex, small
Vertex.
vortex.
Okay. Okay. It's
Yes,
a
yes,
small turbulence vertexes created inside that.
yes,
Okay.
exactly.
Okay. Okay.
Because of
Okay.
that, it is showing continuous continuity.
Fine. 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 Okay.
Yeah,
Right. Thank you. Thank you very much for
yeah,
that.
yeah. Okay,
Thank you. Last week,
yeah.
actually, whether your this one was uploaded because I could not see the.
No, no.
Uh,
Last week also we were discussing this same lecture because Partha said that he did not go through this. So this week again we went through this one, and since he had studied, we were like just discussing some doubts or anything left over. Okay, so you can just go through this one. Next week we'll see the 12th one. If
sure.
you
Sure.
missed the
Sure.
last video, you can see this one again. It's the same. It will be same.
Oh, okay. Okay. Fine. Fine. Thank
Yeah,
you.
yeah,
Thank
it
you
will
so
be
much.
same. Yeah.
Thank you. Yeah.